5 steps to balance the redox reaction. Hi, my name is Dr. Ain. In this video, I will share with you 5 steps to balance the redox reaction in acidic condition. At the end of this video, we will be able to balance the unbalanced redox reaction in acidic condition. In balancing redox equation, we need to differentiate between the oxidation and reduction. Two main tips to differentiate the oxidation and reduction. Remember, oil, rig, and relate with electron. So oil is oxidation is loss. I mean loss of electron. And reduction is gain of electron. So the second tips for oxidation process, increase the oxidation number from reactant to product. And for reduction process, decrease the oxidation number from reactant to product. So please recap what is the oxidation number from previous video. Okay, let's move to how to balance the unbalanced redox equation in acidic condition. The first step is write the unbalanced equation for the reaction in ionic form. For example, the equation shows the unbalanced equation for the reaction between iron and dichromate. For step 2, separate the equation into two half equation. Equation 1, so Fe2 plus produce Fe3 plus. And equation 2, Cr2O72 minus produce Cr3 plus. From both equations, we can identify the oxidation and reduction based on the oxidation number. Okay, for iron, so oxidation number for iron increase from +2 to +3. So increase in oxidation number is oxidation process. And for Cr, oxidation number for Cr is, please calculate the oxidation number for Cr, and then we get +6. And then after reaction, the oxidation number of Cr is +3. So the oxidation number of Cr decreased from +6 to +3. So the Cr is reduced. Okay, for the step 3, balance each half reaction for number and type of item and charges. Okay, if the equations have oxygen and hydrogen, so we ignore it for a while. For example, in half equation 1, so Fe2 plus produce Fe3 plus. Okay, so 1 Fe produce 1 Fe. So now Fe is balanced. There are no oxygen and hydrogen in this equation. So we continue to balance the charges. So one tip to balance a charge is we can place an electron at side which have high oxidation number. At left side, we have two oxidation number, so Fe2 plus. So we have two oxidation number. And at the right side, so we have Fe3 plus, that means 3 oxidation number. So we can place an electron to the side which have high oxidation number to place or to balance charges. In this case, we place electron at the right side. Okay, at the right side, that I mentioned before, have plus charge is +3. So we add one electron minus 1. So now the charge is +2. Okay, now the charges for the both sides are balanced. Remember that the half equation 1 is the oxidation process which Fe lost an electron to produce Fe3 plus, and the oxidation number of Fe2 plus increased to Fe3 plus. So half equation 1 is oxidation process. Okay, let's move to half equation 2. So balance half reaction for we focus for the number and type of atom first. So we need to ignore the oxygens. Okay, focus on only for Cr. At left side we have 2 Cr, but at the right side we have 1 Cr. So we need to balance the Cr first. Okay, so we put 2 as coefficient for Cr at the right side. Okay. Okay, now Cr is balanced. Next, we balance the oxygen. To balance the oxygens, we add H2O to side which have less oxygen. Okay, at left side we have 7 oxygen, so we need to add H2O to the side which have less oxygen. Okay, now Cr is balanced. To balance oxygen, so we add H2O. So the amount of H2O added equal, okay, equal to the amount of oxygen atom at reactants. Here we have 7 oxygen. So we add 7 H2O at the right side. So in this case, so we add 7H2O. Now we need to balance the hydrogen, the H. To balance the H, we add H plus. Okay, so how to add the H plus? Okay, so we add, in this case, at the right side, we have 7H2O. That means 14H. So we need to add 14H plus at the left side. Okay, next. Now, we need to balance the charge. From the equation, at the left side, that means plus 14 minus 2. That means the charge for the left side is plus 12. At the right side, that means 2 times 3 plus, that means plus 6, and H2O have no charge, 0. So the charge at the right side is plus 6. So remember to place an electron to side which have high oxidation number. So at the left side have high oxidation number. Now we balance the charge. Okay, so here the left side have high oxidation number, so we add electron at left side. So we add 6 electron to balance equation and to balance the charge for both sides. Now equation 2 is balanced. Next, we continue for step 4. In this part, we add two half equations and balance the final equation by inspection. The equation on side show the two balanced equations. If necessary, equalize the number of electrons in the two half reaction by multiplying the half reaction by appropriate coefficient. For the reaction shown on this slide, we multiply the equation 1 with 6. So now the equation 1 and equation 2 have the same number of electron. We have 6 number of electron. So add the two half reaction together and balance the final equation by inspection. Okay, the number of electron for both sides must be cancelled. We have 6 electron at the right side and 6 electron at the left side. So we need to cancel the number of electron. And then for step 5, we need to verify that the number of atoms and charges are balanced. Now the equation are balanced. We have 2Cr, we have 2Cr at the right side, 6Fe, 6Fe, 14 hydrogen, 14 hydrogens, and 7 oxygen, 7 oxygen, and the overall charge for both sides is 24. So now the equations are balanced. Okay, thank you for watching this video. So I hope now you know how to balance redox reaction. Don't forget to do an exercises related to this topic. Bye. See you next video. Assalamualaikum.